And we are perfect in time, and now we are also perfect along the process chain. And we are coming to Mr. Ortmann, who will talk about connecting aluminum and copper and other metal foils. And but we had a talk before, and it's not, let's say, contacting the electrode sheets. It's more contacting cells together, and it's a new system called eClinching. And Mr. Ortmann, who is responsible for this development, and he will talk about that today.
Hello, it's a pleasure for me to be here in front of you. Well, in the today's presentation, we saw several slides, information how to produce cells. But at the end, I would like to show you also how to connect different elements of the battery. And I would like to give you an overview about the eClinching. Maybe you don't hear about eClinching, but I will say eClinching is more or less similar, and what you could keep in your mind, crimping of wire. Wire you use crimping, eClinching you use for bus bars or similar elements. On the example of aluminium, joining with aluminium or aluminium with copper, I will go later in some details. But before I will jump into the details or the solutions for different challenges to join aluminium, I would like to show you examples where our technologies, not only the eClinching, also other technologies, is already in place. Add battery elements, means structural elements, battery housing, battery tray, battery modules, as well electrical connections, battery cell connections, but also we are supporting to produce battery cells in the stacking process. When we are talking about eClinching, it looks like a simple process, but there's some magic behind. The magic are the process parameters. The punch press the joinable sheets into the die, and two key parameters automatically produced. The interlock, which is a key element for the holding forces, and the dimension X, which is more or less a bottom thickness. This bottom thickness or dimension X is an easy, accessible quality indicator. By this quality indicator, you can prove and control the performance of your electric connection at all. Because this is linked, these parameters is automatically linked to electrical resistance. To produce these eClinching joints or connection, we have several tools or point geometries in our portfolio, and you will see some examples, few examples of that. My favorite of these joints, don't misunderstand the wording here, my favorite of these joints is a twin point. It has three major advantages. First, automatically an anti-rotation feature. Second, you make two dots in one step. You have automatically a much higher holding force compared to a single point, close to double. And last not least, you have a higher and better conductivity due to increased contact surface. I mentioned when we are talking about joining aluminium with copper or other materials. We all know from history that aluminium is more often used in automotive industry or other areas. But to join, to connect aluminium with other materials or also with aluminium, there are, I name it, challenging aspects. First challenge is a creeping. Second challenge is a hard oxide layer with insulation effect. And the third is a contact corrosion in humid environment. Moving now to the first challenge and the solution, what eClinching can offer. As I mentioned, you can easily compare the eClinching with crimping of wire. By keeping this in mind, the best combination for joining elements, conductive material, for example, is a mixture, is a combination out of material, force, and form bound to prevent creeping in the contact area or relaxation in the contact area. How to achieve this? At the end, you need to apply mechanical stress And as I said, when we are compared in mind with crimping, you have also in crimping a kind of compression ratio that you can and need to consider on the eClinching as well. So to have an optimized compression ratio at the eClinching process, you need to use at the end the optimized process parameters, which I mentioned before, and others, as well as the optimized tools. By this, these process parameters will be defined in our TOX lab and also registered in our test report that will be provided then later on to you, that you have the same performance as we evaluated in our TOX lab. And you can see it on the diagram that the electrical performance is very good of this clinching or eClinching point. So coming now to the next, and when we are talking about conductivity or connection of conductive materials, we are talking always about contact zone, contact surface. And the eClinching provides you two kind of contact areas, contact features, I would say. One is the contact zone. Second is also cold welding. Due to that, during the eClinching process, the surface flows in each other. We apply mechanical stress and friction. For example, the hard oxide layer of the aluminium breaks up automatically. We generate micro bridges and cold welding, what you can see in the shining, in this kind of lighting, as well as the structure geometry on the right picture of the aluminium surface, and the shining picture or shining elements of the copper point. So, due to this process of the eClinching, we generate a large, besides the contact surface, we generate also a large number of microbridges. This is a root cause, the reason for this low electrical resistance or the good high conductivity. Moving now to the last challenge, which is honestly a bit critical when you're joining aluminium. So we are talking about the contact corrosion. And the harshest environment is to apply salt spray. What you can see here, and this is also the background of this eClinching and the performance of this eClinching geometry. Due to this process, we prepare enclosed geometry. Due to this moisture cannot enter into the geometry. And this was proven by an investigation with the University of Dresden, as you can see in the diagram. So this salt spray has a low impact in the conductivity of the eClinching. So after sweet challenge, what I showed you, I will give you also further information what kind of application we already have in place or is already using the eClinching technology. What you should keep also in your mind is that eClinching is not only limited to join same material thickness. You can also join different material thickness, as you can see on the diagram on the right side. And what you can see here in this overview of application samples is that eClinching is applicable to join low voltage as well high voltage application, split according automotive standard. Now, more or less at the end of my presentation, and to summarize, the eClinching provides you a solution to meet your requirements in an easy and robust and reliable way. Because we prepare in an easy step a gas and liquid tight connection with low resistance. And the connection is also possible of more or less surface, doesn't matter. You can use plated materials, so you can use it without surface treatment. That's all from my side. I know I was a bit quick, but thanks.
But quick means we have enough time for questions. So are there questions from the audience? If not, then maybe I start. I think in the pictures you showed always two foils which are connected together. Is it possible to have more foils?
Yes.
And then maybe the next question, could you also think about using this internally, also inside the cell, you know, to connect the different electrode sheets with copper or something what
Yes.
is going out the cell?
That's an interesting question also for this audience. What we already joined in investigation modes also with other customer is we joined multiple layer of busbars. We joined multiple layers of foils, up to 40 foils until yet. And we also joined solid busbars with compacted wire strains, which are typical application of battery applications like battery cell connection, or as you already mentioned, the battery cells themselves, as we also saw in the process. They are used sometimes ultrasonic welding, also laser welding.
And you just said ultrasonic and laser welding. Do you know let's say, the difference in resistance also over the time of the process?
What we see, based on our feedback from the customer, is that the electric resistance of eClinching is similar to common used joining methods, crimping and ultrasonic welding.
Okay. So are there now some questions from the audience? If not, my 2 questions are over. Okay, then thank you very much again, Mr. Ortmann.